Okay, now let's talk about factoring by substitution. So if I have this problem, x to the fourth minus x squared minus 12, well, this doesn't look, it's a trinomial, right? But you say, well, that's degree 4, okay? So it doesn't look like it's a trinomial square or a quadratic trinomial. However, you notice that x to the fourth and x squared are related in such a way that this is really the square of this, right? Namely, x to the fourth can be written as x squared, the quantity squared, minus x squared minus 12. So when I say substitution, what I mean is maybe we can, for now, call x squared some other variable. Let's say we can let y be equal to x squared, okay? And if we do that, we'll see that our new problem becomes factoring y squared minus y minus 12. So y is x squared, so that becomes y squared, right? Minus y minus 12. And this is now a trinomial square that we can factor. We can think of two numbers that add up to, or multiply to negative 12 and add up to negative 1, and 4 and 3, right? They're good candidates, okay? And of course, if we put 4 as negative, negative 4 plus 3 is negative 1, and negative 4 times 3 is negative 12. So we have the factored form y minus 4, y plus 3. But notice we're not quite done yet because we just factored this expression. We have to go back to what y was originally, okay? So y was really x squared, so therefore we put back y. Y was x squared, so you have x squared minus 4, x squared plus 3. We always want to check if we're actually done with our factoring. We notice that x squared minus 4 can still be factored, right? It is the difference of two squares. So we can factor this some more and get x minus 2 quantity times the quantity x plus 2. X squared plus 3 being the sum of, well, this 3 is actually not a perfect square. So this cannot be factored anymore. This is prime or irreducible. So we stop here, and that's our final factored form. Let's look at another example. If we have y to the 6 plus 7y cubed minus 8, again you notice the relationship y to the 6 is really the square of y cubed, right? So let's show you that. This is really y cubed squared plus 7y cubed minus 8, okay? So in order to reduce this to something that we easily can recognize, maybe we can for now call y cubed something else. Let's say we can call y cubed x. Use a different variable so it's not confusing, okay? So then the new problem becomes x squared plus 7x minus 8, okay? So we are interested now in factoring this, and hopefully we are at home with this type of an expression, okay? So this is a trinomial square or quadratic trinomial. Again, the leading coefficient is 1, so it's easy. We just want to think of two numbers that will multiply to negative 8 and add up to 7, right? So those are what? 8 and negative 1, right? 8 plus negative 1 is positive 7. 8 times negative 1 is negative 8. So therefore, the factored form is going to be x plus 8 and x minus 1. That's as far as the letter x is concerned, okay? But remember that x really was y cubed, okay? So you go back to what x really is, and it's y cubed, and then you have so y cubed plus 8 and y cubed minus 1. And now we remember this from our binomials, right? You have a cube plus another cube, and this one is a cube minus another cube. So these two factors in turn can be broken down or factored some more. The first one is the sum of cubes, and this is the difference of cubes. Let's review how to do that. So for cubes, we said there's a short and a long, right? So that's for this first one, a short and a long for the second one, okay? Y cubed plus 8, so you get y, and then essentially you ask what 8 is. It's 2 cubed, right? So you need a 2, or you can think of cube root of 8 is 2, okay? Y plus 2. In order to produce a y cubed, we need a y squared, right? Y and y squared is y cubed. In order to produce an 8 from a 2, you need to multiply it by a positive 4. And remember our Mr. Fix-It, right? Mr. Fix-It, you need to put the minus 2y in the middle, okay? For y cubed minus 1, again, the first factor is y minus 1, right? In order to get a y cubed, we need a y squared. What do we multiply to negative 1 to get a negative 1? We need a plus 1, right? And then we need to do a Mr. Fix-It. That's going to be plus 1 times y, which is plus y. So that's this final step here is the factored form of the original problem that I gave. So next, if I have y to the 9th plus 8 z to the 12th, so here notice I have two things, right? Two terms, so I have a binomial. Now for binomial factoring, you just want to reduce each of these into either 2 squares or 2 cubes, okay? So you try to figure out, can I write this as a square plus a square, or a square or a cube plus a cube, okay? Well, the exponent being 9 here and 12 here, and that's an 8, that suggests that probably you have a better chance transforming this into a cube plus a cube, right? So let's see if that works, okay? So y to the 9th, how can we write it as something cubed? So y to the 9th is really y to the 3rd and then raise that to the 3rd, so 3 times 3 is 9. Okay, so you have a cube. Now how can we write 8z to the 12th as something cubed? Well, 8 you know is 2 cubed, right? So that's 2 cubed. And z to the 12th, applying the properties of exponents, can be written as z to the 4th raised to the 3rd, right? 4 times 3 is 12. Okay, then we can use substitution if you want, right? So we can let's say a be y cubed and let b be 2z to the 4th. So if we use those two substitutions, we need to use two different letters because these are different, okay? So then you'll get a cubed plus b cubed. And this is our famous sum of cubes, right? So we know that the factored form is a short and a long, right? The short is the a plus b. The long is a squared to produce an a cubed, a b squared there to produce a b cubed, right? And we have our Mr. Fix-It, which is minus ab, okay? But again, we want to go back to our original variable, so we have to just replace a by what it was, which was what? Y cubed, right? So you have y cubed plus b, which is 2z to the 4th. And then a squared, now be careful, a is y cubed, right? So the cube of y, the square of y cubed is y6. In fact, maybe you can just look here, right? So the square of this is y6 minus ab, so you multiply these two is minus 2y cubed z4, or you can substitute if you wish, right? And b squared is going to be the square of b. The square of 2z to the 4th is 4z to the 8th. Okay? So that's how substitution works for this particular problem. Okay, let's look at this next one. I have 8 times the quantity x minus 4 squared plus 10 times the quantity x minus 4 minus 63. Again, our instruction is to factor this expression. Now you see the occurrence of the quantity x minus 4 twice here. So maybe for now we can call x minus 4 something else, okay? It doesn't always have to be x and y. So let's see. Let's say you want to call it n. Let n be x minus 4. So then the new problem we are looking at is factoring 8n squared plus 10n minus 63. So this is a lot easier to look at than this one, right? Okay? And hopefully you recognize that this is a trinomial square. Leading coefficient is 8, okay? No common factors, so I guess we can just use our AC bottoms up, okay? Or AC grouping if that's still what you prefer to use, okay? So let me just summarize, organize my information here using this diagram. So I'm looking for two numbers that multiply to 8 times negative 63, right? And we'll add up to 10. I don't see a 10 being produced by subtracting these two numbers, so I break this down some more. I guess 63 I can write as 9 times 7, right? I still don't see any light here getting a 10, so I guess I can break down 8 into 2 times 4, okay? So let's see, I think maybe I see something happening already. If I have 2 times 9, 2 times 9 is 18, right? And 4 and 7, 4 times 7 is 28. 18 and 28, you hear a 10, right? When you subtract 18 and 28, there's a 10 right there, okay? Well, the product is negative, so one of these guys will have to be negative. Now, since we want positive 10 for our answer, so the negative should be the... Wait a minute. So, what did I... No, this was wrong. This 2 times 9 is 18. Oh, I have to rewind that. Okay, so I have 2 times 9 is 18, right? 4 times 7 is 28. So I have 28 minus 18 will give me a 10. The 18 has to be the negative, okay? So therefore from here, well, we're not quite done, then we have to do our bottoms up, right? Which is we divide both numbers by the leading coefficient, which is 8, okay? Divide by 8. Reduce to lowest term, so 28 divided by 8, they're both divisible by 4, so I get 7 halves, right? 18 and 8 are both divisible by 2, so I'll get negative 9 over 4, right? Okay? So therefore, if you do bottoms up, the first factor is going to be 2n plus 7. The second factor is going to be 4n minus 9, okay? So we have factored this as this, and we can check that we got the correct factors, okay? But now all we have to do is go back to our original variable, which was x. N was x minus 4. So you just replace n by x minus 4. N by x minus 4. And simplify this to get the correct factored form for this, okay? So we were able to factor this without having to, you know, expand this and so on and so forth. This is the answer. So let me see. If I simplify these quantities, I'll get 2x minus 8 plus 7. So that's going to be 2x minus 1, right? 4x minus 16 minus 9. So that's going to be 4x minus 16 minus 9 is minus 25, right? Okay, I hope I did that correctly over there. Okay, so that's how you do it. Factor it by substitution.